Okay, so P7.4, more about alpha, beta and gamma. Okay, so far what we know about alpha, beta and gamma is we know that alpha has the symbol like this. It has 2 protons and 4 neutrons. So we can put that into a little table that's going to be useful to us. So we'll say name, symbol, atomic number, atomic mass. Okay, and then we can say that beta has this symbol, an atomic number of -1, atomic mass of 0, approximately 0, it's not quite 0, and gamma, atomic number 0, atomic mass 0. So they're the things that we know so far. So that's everything that we know so far. Just put into a nice simple table just to help you to remember atomic number and atomic mass. Atomic number is the number of protons. Atomic mass is how much it weighs. So how many protons and how many neutrons it has combined. Okay, and then I'm going to add some more columns here as we go through this next bit. Okay, but that's what you know so far. Okay, so the next thing we're going to talk about is we're going to talk about ionization. Ionization is, let's say you've got an atom here, it's nice and happy, and it's got an electron in orbit here, let's say. Okay, and then you've got some radiation comes in and hits this electron. Now, if that bit of radiation has enough energy, it can cause that electron to be knocked out of orbit. Okay, so if you've got 2 positives here and you've got 2 negatives here, this atom is nice and happy because it's got the same number of positives, it's got negatives, it's completely stable. But in comes some radiation and hits that electron. The electron is then knocked out, and what we're left with now is we're left with something that's got 2 positives, 2 neutrals, but only 1 negative, and the other negative has been emitted. Okay, so it's emitted that electron. This is now an ion, and an ion is something that has gained or lost an electron. In physics, it nearly always is lost an electron. In chemistry, you can gain them as well as part of a chemical reaction or as part of electrolysis. And in terms of how ionizing something is, so how ionizing something is depends on how much energy it has. And the bigger you are, the more ionizing you are. So alpha particles, they're highly ionizing because they're huge, okay? And gamma particles are weakly ionizing compared to the other 2, and these ones are medium. Okay, so how ionizing are you depends on how big you are, and as you can see, this one's the biggest, this one's the next biggest, this one's the smallest. It's got 0 mass, but it still has enough energy to be ionizing. It just doesn't do it as easily as the alpha or the beta. Okay, so that's the first thing, ionization. Second thing is how penetrating they are. Okay, so what I mean by penetrating, I mean how easily do they go through things. Okay, we call that penetrating power. So penetrating power. And the experiment that you do this with is you look at different thicknesses of material and see how do different substances go through them. So to start with, you might have an alpha particle, and if you have a detector and then you just move your detector further away, you'll notice that it decreases, and that's because the range in air is about 5 centimeters. Okay, so alpha can't even penetrate through air if it's more than 5 centimeters. Beta in air is about a meter, and gamma in air is infinite. Okay, it will just keep going. Air is not going to make a dent on gamma. Okay, but that's not all we want to know. We want to know, what about other substances other than air? Okay, so we might want to say, let's see what happens if we have, so if we have our alpha, we have our beta, and we have our gamma, and we put in front of them a sheet of paper. Okay, well, what happens is that the alpha particle doesn't get through that sheet of paper. It can't make it through that sheet of paper. The beta particle does make it through that sheet of paper, and the gamma particle makes it through that sheet of paper. Okay, now if I increase the thickness of that paper, then less beta would get through. So one of the uses of beta radiation is to measure the thickness of paper, because the thicker it is, the more particles get stopped, and the thinner it is, the more particles get through. So you can use that for measuring thickness of paper, and I'll show you the machine that uses that in a minute. Gamma rays are no use for this, because they'll go through the paper regardless of how thick it is, and alpha is no use for this either, because it will get stopped regardless of how thick it is. So only beta can be used for the thickness of paper. So the next thing that we do is, if we put a sheet of aluminium, so just a thin sheet of aluminium in the way. So this one was paper, and this one is a thin sheet of aluminium. This time the beta is stopped, but the gamma carries on going. And this time what we do is we put something even thicker in the way. And we put a piece of lead in the way. And what we notice then is, no matter how thick that lead is, gamma is reduced by lead. You can't stop it completely, but you can nearly stop it completely. So we say that it's reduced by lead. So let's add those two to this table. Okay, so what we want to know first was, we want to know what the range in air was. So we said that this one was less than 5 centimeters, about 5 centimeters. We said that this one was about 1 meter, and we said that this one was infinite. And we also said, what's it stopped by? And we said that this one was stopped by paper. And we said that beta was stopped by aluminium. And we said that gamma was reduced by lead. Okay, that's the next set of things that we need to know. I am terrible at drawing tables. And that is a summary of everything that you need to know about alpha, beta and gamma. Okay, their symbol, what they do, their charge, their mass, how ionizing they are, how far they go in air, and what they're stopped by.